Lesson 55 is solving systems of linear equations by graphing, so you will be doing a lot of graphing. If you have graphing paper, it would be wise to use it at this current moment. So if you have it, get right. If you don't have it, you tend on drawing a lot, and you're going to need it to solve your assignment. So it was on your list of things you will need for my class. Please use them now. Okay, example 1. So we're going to go over some reminders here. I do this every single time, so you should be used to it and probably annoyed by it. M is your slope, your rise over run. It is your rate of change. Okay, this is your y-intercept. Or if you're graphing it, it's 0, b as a coordinate pair. Okay, so we're going to use that little bit of knowledge quite a bit today. So starting with example 1. Example 1 will tell us to find, tell whether this is a solution for the given system. So they give us two equations, 3x plus 2y equals 7. And I always write them side by side and kind of separate it into columns. And then x equals 7 minus 3y. And it says, is 1, 2 a solution for the system? If it is a solution for the system, it will be true for both numbers. If it is not true for one of the numbers, then it is not a solution for this system. So I take 1 and I plug it in for x, so 3 times 1, plus, and then I take my y and I plug it in for y, so times 2 equals 7. And we got to figure out if that's true or not. Same thing here, 1 equals 7 minus 3 times 2. And we're going to see if that's true. So 3 times 1 is 3, plus 2 times 2 is 4, equals 7, 7 equals 7, so that's true. Here we get 3 times 2 is 6, 7 minus 6 is indeed 1, so 1 indeed does equal 1, so it's true. So since it's true for both of the sets, or both of the equations, then it is true for the entire system. Remember, systems operate together, so you have to be true for both. It is a and kind of a thing. It has to be true for this one and this one. Okay, so when you're checking those, that's what you have to do. That was part A. For part B, we're going to find it for 2, 3. We're going to have two different equations, 3x plus 2y. This time it equals 12. And then it says x equals 7 minus 3y. And again, I'm plugging in the coordinate pair 2, 3. So 3 times 2 plus 2 times 3 equals 12, hopefully. So that turns into a 6. This also turns into a 6. It should equal 12, and it does, so it checks out. Next, I'm going to plug in that one minus that plug-in. I'm going to start to solve. I get 7 minus 9 equals 2. What is 7 minus 9? Negative 2. Negative 2 is not equal to positive 2, so therefore this is not a solution. Okay, so this is not a solution for a system, for this system. Okay, any questions? It's the easy part of this lesson. We're going to start graphing here in a second, so ask now. Okay, this will be how you check your answers once you get them, so you have to be able to plug back in and see if that's correct. Example 2, and I'm going to be doing this on graph paper primarily, but I'm going to make sure my equations are good first. Y equals x plus 3 and y equals 2x plus 1. Now, I know that I want to see things in y equals mx plus b form. Are these in y equals mx plus b form? Yes or no? Yes, they isolated the y. That's the whole point of y equals mx plus b, is we isolate the y. So since both of these have the y isolated, they are in the proper form. I'm going to graph them on one graph. Okay, so this is example 2, and I'm going to graph them on one graph. Okay, create an x and y axis. Okay, they have arrows. Okay, so I'm going to graph the first one. Y equals x plus 3. Where do I start? Okay, so we need to start all the way at the beginning because we don't know what y equals mx plus b is anymore. Is that correct? I don't want to waste my time or yours. And start the y-intercept. What is the y-intercept? It is 3, so it's 0, comma 3. So I plot that point. What is my slope? My slope is not x. Slope is a number. It's the thing in front of the x, so what is it? What is the thing in front of the x? It's a 1, right? Finish these notes tomorrow.